So hello, everyone, and welcome. We've got a few minutes before we get started, but we thought we'd let everybody in, and especially those of you who've been waiting for a little while. Thank you so much for joining us for today's webinar on careers in planetary science and astrobiology. And actually, while we're waiting to get started, before we get started, I've got a warm-up chat for everybody to join. And this is all of our participants and all of our attendees. So our warm-up chat while we're waiting to get started is thinking about one skill that has helped you so far in your career. This webinar, we're going to have people who are more experienced, as well as we have a broad range of people attending all the way. We've got a lot of grad students, a lot of undergraduates, many postdocs, some high school students. We've got a big range. And so especially for those of you who've had something that's helped you in your education or in your career, I'd like you to think about one skill that's helped you so far. And whenever you're ready, just go ahead and enter it into the chat. Got a couple good things so far there. Yeah. Awesome. Feel free to enter things. Wonderful, wonderful suggestions and recommendations. And while people are entering their thoughts, for all of our panelists, if any of you would like to comment on something yourself that has been particularly useful in terms of a skill for your career or career preparation.
Never fear asking questions. That's one of the top ones for me, you know. We're all just apes in a rock in space. Like, it's fine. Just ask things. Don't worry.
Mine follows on from that. Never be afraid to say you don't know the answer. If you're asked something, you can get yourself in a lot more trouble if you try and wing it. It's absolutely fine to say, you know, I don't know the answer to that, but I can look into that and get back to you.
Excellent.
I'll go a different direction, and I'll say learning to code. Does it let me be adaptable and contribute to spaces where maybe I wouldn't have contributed as much?
So
I love that one, Jen. I was going to say something similar, so now I have to change it. I'm going to say questioning the question. There's a lot of very traditional ways we do things and we approach things, and stopping and questioning those questions, those methods, and then seeing if there are newer ways or a different approach is, I think, a really strong skill to have.
awesome. Thank you so much. And Yolanda, please go ahead and change your name. Thank you for joining us. So welcome everyone. And it is time to get started. And I know normally we allow people extra time to join. However, we've got a lot to talk about today. We've had so many questions submitted by so many of you. We're so delighted about that. I am going to start off with a question for all of our attendees. And my first question is, it's a poll question. I hope that it works for everyone, depending on how you're joining the Zoom. Which describes you? Are you a grad student, an undergraduate, a postdoctoral researcher, a professor, a scientist, a science enthusiast, somebody else, an educator, instructor, or teacher? None of these. And we're going to go ahead and let everybody, and you can pick more than one because you can be more than one, as some of our panelists are, as they will tell you in a few minutes. And I'm going to give us about 5 more seconds for people to finish answering, those who can. And 4, and 3, and 2, and 1. And just to show everybody who is who is present with us today. We've got a lot of grad students. We've got a fair number of undergrads, postdocs, scientists, researchers, science enthusiasts, educate. We've got a little bit of everything, including some who are none of these. So that's good for everyone to know. Thank you all so much for joining us today. So our session today on careers in planetary science and astrobiology, let's let you know a little bit more about what we're going to do. This is our agenda. We just did the first poll, and we're going to have all of our panelists introduce themselves a little bit. Then we're going to do one more chat storm, and we're going to hear from our panelists about their journeys. We're going to talk about the past and future careers in planetary science and astrobiology. We had a number of questions about that. We had a number of questions about the different types of careers that you can have in planetary science and astrobiology. And we're going to talk about ways to get started in careers in planetary science and astrobiology. So we're going to be talking about all of these things today. There were a number of questions that fell outside of these categories that we intend to address in future webinars. So stick with us and come back for those. Let's go ahead and get started. Our panelists, Aloy, would you mind introducing yourself briefly? And I'll show your slides in just a second.
Sure. Hi, guys. I'm Eloy Camprubi. I'm an assistant professor at the University of Texas, Rio Grande Valley, there at the very southern tip of Texas. And I'm an astrobiologist. My background is mostly on the biological and biochemical sciences. But, you know, I'm a geologist wannabe, so I also like rocks, and particularly space rocks, a lot. So basically, in my lab, we try to do things as interdisciplinarily as possible.
So, thank you. And Rhiannon, would you mind going next, please?
Sure, I'm Rhiannon. I am the curator of the Oscar Monig Meteorite Collection, which is at TCU. I'm also an associate professor in the Department of Environmental and Sustainability Sciences. But I am a geologist by training, so I'm particularly interested in how we form the crusts of differentiated bodies. And I look mostly at meteorites from asteroids to address that problem.
You and Jennifer.
So, hello everybody. I'm Jennifer Piatek. I'm a planetary scientist. Started out in physics, but switched to geology because planets are mostly rocks. I do mostly remote sensing, and my focus recently has been on Mars. But most of my time is as a professor in the Earth and Space Sciences department at Central Connecticut State University. We're a undergraduate only institution, and I'm also chair of the department. So thank you.
Thank you so much. And Ed.
Saludos, everyone. I'm Edgar Rivera Valentin. I go by Ed. I'm a planetary radar scientist at Johns Hopkins Applied Physics Lab. I am not a professor. I get to play with great instruments, like when the Arecibo Observatory was functional, I'd zap planets and asteroids. I also get to work on missions like the Mini-RF instrument on the Lunar Reconnaissance Orbiter, the Apophis Explorer mission. My research focus is to leverage radar and other techniques to help facilitate the exploration of the surfaces of bodies, so making sure there's no hazards there, can we land there, and then also doing something called planetary defense, which is making sure we understand asteroids, their shapes, sizes, their orbits, just in case we have to protect ourselves one day.
So the next thing we're going to do is a chat storm. So before I reveal the question, I want to prepare everyone. The way we're going to do this is everyone is welcome to enter something into the chat, but don't hit return at first. Take time to think about it, and then we're all going to hit return at the same time so you can see everyone's answers on the topic and nobody feels singled out or anything. So that's how we're going to do it. And we've got people, as we just saw, with a variety of experiences, both our panelists, but also our attendees. Some of them are more experienced researchers. Some of them are more experienced professors. Some of them are new to all of this. We've got a lot of undergrads. So the question here for everyone to start typing, but don't hit return yet, is what is something related to either your education or your career that you wish somebody had warned or prepared you for, that you wish now that you knew then? So everyone go ahead and take a couple seconds to think. If you already know what you're going to say, you can start typing it, but don't hit return yet. Going to give you about 30 more seconds to think and type. And I'm going to give all of our panelists that same time to think, because I'm going to ask you to say something while the answers are appearing. So, okay, we're going to give you about 20 more seconds before we tell everybody to hit return. Okay, you can all go ahead and start hitting return. A lot of you have already started. So we've got a lot of people on with us today. Thank you all for joining. So we've got a tremendous number of answers here that people have started answering. And while we're all looking through and reading all of those, would any of our panelists like to answer the question out loud?
All right, I'm going to jump in before I forget. I wish someone had told me that you're never going to feel like you are prepared for what you're doing. You're always going to be adapting and learning and doing something else. So get used to it.
I think for me, I wish it had been emphasized that I am allowed to write my own story. I spent a lot of my undergraduate years and some of my years as an early faculty really letting other people dictate where the path took me. And as it happens, that worked out pretty well for me. But it might not have done. And I didn't really take ownership of that. And you're allowed to do that. Take ownership and go, no, that's not the way I want to go.
I just want to piggyback on Jennifer's comment, because I think that's very important. It's something that you don't realize, that like as you're progressing in your career towards whatever end, in every stage of the way, master's, PhD, postdoc, whatever comes, like the job is sometimes slightly different, but often it's actually quite dramatically different. I found this particularly when you go from PhD to postdoc and then postdoc to professor in my case. And it's fine though. You will not know what you're doing, but no one else does either. So it's fine.
So, thank you.
And I am going to echo what Rhiannon said, because I very much resonated with that. Throughout my career, I think people wanted to put what I do and who I am in a box. And like I said, like I do a bunch of different stuff, and I like that because I'm driven by curiosity and passion instead of having a name above my head that says Mars scientist or brines person or radar person. I like to do random things. And learning to unshackle yourself from others' expectations is something that takes time and self-power to do.
And I see lots and lots of great input into the chat as well. As you're all scrolling through it, if you see something that you want to highlight and comment more on, ranging from writing skills and networking skills, and it's okay to reach out and ask questions. It's okay to say you don't know something. Opportunities and funding. We'll get more into opportunities and funding in just a little bit, I promise everyone, because that is going to be part of this. And what expectations are, how much time you're going to spend on things like writing, and what the different types of careers are in astrobiology, the different types of careers in planetary science. We'll get into all of that as well. Research articles. Asking for help does not mean that you are incompetent. I love that. So, and it can be very difficult, incredibly difficult, but if you want it, you can do it. I love that too. So, let's go ahead and we're gonna move along to this idea of the career journeys for our different panelists. And Eloy, I'm going to go ahead and start with a couple of your slides and let you talk to them. So here, and just tell me when to hit return and we'll keep going on them.
Yeah, so this is my path, and of course, your path will always look very different. But I think it's good for people that are interested in planetary sciences and astrobiology to know that it's a boon and a curse that there's no like guided path, right? So it's normal to feel like your background does not align with what you or other people think an astrobiologist should or shouldn't do. But we are in this like little world of space rocks. We all feel like this in one way or another. So in this case, I'm going to describe what I did, but just know that that doesn't mean that, that's the only way. In fact, it is like a 0.5% of all the possible ways. So I'm originally from Spain. I grew up in Barcelona and I did a bachelor's in biology and biochemistry there. You can go next. And then in 2012, I moved to London where I did a master's in biophysics and at UCL. And then right after, a PhD in chemistry. And at that point is when I started moving into what at that moment, I didn't know it was astrobiology because I started my career fully with origin of life. So I've always been very interested in knowing why and how a barren rock that has no life suddenly then develops it. Like what drives that and how does it happen? And what does that tell us about the chances of life springing up in other planets? So that's when I started my sort of astrobiology journey. But at this point, I was still not on the space side of things. I was still like Earth, okay? Then I moved into the Netherlands to Utrecht as an Origin Center fellow as my first postdoc. And there is when I started learning that, oh, okay, so Earth is just a planet. And it's a cool one at that, but there's many other planets and planetary bodies. So can we apply some of the stuff that I've been working on Earth about the ocean, the early ocean and the hydrothermal systems? Can we apply that to study Europa and Enceladus and other moons? Next, please. And then just briefly, during the weird COVID years, I spent some months in Japan at ELSI, Earth Life Science Institute, also going even deeper into the space sciences. And that was right before I got my current position here in Texas as an assistant professor, which means I'm a professor in trial. There's like 5 years of trial period. So any year they can decide to get rid of me and, if I don't screw up too bad, they will be stuck with me. So that's the goal.
And so I thought you could also talk a little bit about some of these different places that you've been to and why as well, before we move on to the next person.
Oh, in my case, I guess it's always because I never, and that's only my path. I've been always very stubborn. So once I realized, oh, this astrobiology thing is my thing, it didn't even occur to me that I would go and do and join a lab that was doing other things, right? Because of that, and I was very stubborn on the topic that I wanted to work on, even though I use sometimes more biology, sometimes more chemistry, sometimes more geology, it was always within the umbrella and the topic of astrobiology. So in my case, I was very stubborn about that, which meant that maybe I had to be a little bit more flexible about where. Okay. So, I mean, hey, if you have 4 Nature papers by the time you finish your PhD, maybe you can be stubborn in your topic and in where you do it. So, if that's the case, by all means, the more strength to you. In my case, I didn't. So it meant that if I wanted to keep doing what I wanted to do, maybe I had to like move universities and countries. Luckily, I like doing that. But if you hate that idea, then maybe you need to be prepared to actually be a bit more flexible on the topics that you work on.
Thank you. All right, I'm going to go ahead and leave this up for just a second. Among our panelists, who would like to talk next a little bit about your career path?
I'm happy.
I can go ahead, Rhiannon.
Okay. So I wanted to be an astrophysicist. when I was 16. I was living in England at the time. It's where I grew up. And the career advisor told me that I would never get a job in astrophysics, that it was a stupid, sure she didn't use that exact phrase, that it was just a bad choice and that I should choose physics because I would be inherently more employable. And I applied for physics degrees, kind of with a space science extra portion. In England, the system is very different. You're kind of required to go where you accept. And the day my exam results came out, I turned to my mother and my father, bearing in mind my mother was my principal, and said, I don't want to do physics. I kind of went along with this, but the idea of spending the next 3 or 4 years doing this just makes me miserable. And to their credit, they said, what do you want to do? And I ended up choosing a university just because I liked the city, Edinburgh. And I went off to do geophysics purely because I liked an archaeology show that had geophysicists on it, where they got it wrong every week, but they came back every week, which at 18 seemed like a sweet deal. And while I was there, I fell in love with geology, and I switched to a geology major within my first year. My parents always laugh at this because like my life is a constant stream of luck, it feels like in that way. And then in my 4th year of my geology degree at the University of Edinburgh, Dr. Rhiannon Jones, who at the time was at the University of New Mexico, came to gave a science talk at the University of Edinburgh on meteorites. And I said, aha, that's the way I do space and geology. And it never occurred to me to not apply for PhDs. I never even thought about getting a job. So when people ask me, how did you decide to go to grad school? I don't know that I did. I just didn't think of anything else. And so I applied for a couple of positions in the UK, but there weren't as many opportunities. And I was accepted at the University of Tennessee and never really looked back. My parents at the time said, this could work out really badly for you. Do you think this is the right approach? And I said, I'd rather go and know that it didn't work out than not go and always wonder. I was fortunate enough to get a postdoc at the Natural History Museum at the Smithsonian as soon as I graduated. And I had a 3-year fellowship there. But literally after being at the Smithsonian 3 months, the job that I currently hold was advertised. I didn't really want to apply even. My postdoc advisor, Tim McCoy, who's the curator in charge at the Smithsonian, said to me, your job has been advertised. And I said, my job? And it was because I took delight in playing in the US National Meteorite Collection. I loved being in the vault behind the scenes. I had become very involved in public outreach at the University of Tennessee, but I also miss teaching. And so my role is I'm half professor, but half curator, which really means I'm 100% of both, and I'm always overcommitted, but I love it. And so this is, at the time, was the only job that I had ever applied for. And I wish I could meet that career advisor that gave me that advice at 16. And this is why I say you're allowed to write your own chapter, right? This could have ended up somewhere very differently for me. And I was lucky that I find my way back around to a career that I love. But yeah, I could have ended up, I don't know, on some archaeology show where I got it wrong every week.
Thank you. Thank you, Rhiannon. And Jennifer, who would like to go next? Jennifer, I think you are.
I think I'm going next. That's fine. I think I'm starting to see sort of a through line, and we'll have to see if Ed follows through with this, that for all of us, we came from very kind of different places and fell into planetary science and astrobiology. We're really interdisciplinary. So you can come in with all kinds of backgrounds and fit in and find a niche into which you can fit your work and your passion. So I started out, I think, as I said, in physics because I went to high school in Connecticut. So I'm up in New England, and in Connecticut, we don't teach earth science at the high school level. So I hadn't thought about rocks for who knows how long, but physics was cool. And I liked physics, and it's astronomy adjacent. And so I went off on that path, but I really did want to study Mars, and Mars is rocks, and I found that out. Got to study rocks. But I got involved in undergraduate research, and that literally was, there was one geology professor who had some telescopic data on asteroids that he needed students to do to really just do the busy work. And that pulled me in. So I learned about geology first in the infrared and learned how to work with asteroid spectra. And then you're absolutely right. Geology rocks. I love it here now. I went off for a master's degree at Arizona State. So for the folks that don't know the geography of the US, we're going from the eastern side to the western side. I came back, did my master's degree looking at spectroscopy of rocks relevant to the Mars surface, preparing for, we'll say Mars Global Surveyor and leave it at that. Then I moved moved a little bit back east, went back to Pittsburgh and started doing theory, sort of radiative transfer theory, looking at HAPI theory and how you can model the reflection of light from planetary surfaces. But I missed my geology and I missed my Mars. So when I did a postdoc, I had a chance to go to Tennessee, where Rhiannon was a graduate student at the time, and went back to doing spectroscopy of Mars and remote sensing. And then, yeah, I'm gonna have some love for the radiative transfer. I love HAPI modeling. It's really a fun thing. I wish I could do more of. But the job I have now is with undergraduates. And so I've got to kind of think about the ways that my research can be adapted to a student who wants a semester long little chunk of a project that doesn't require like differential equations and coding and all of that stuff. And that's, I mean, that was lucky for me that it came full circle like that I actually ended up almost back where I started. I live now about 30 miles from where I grew up. It was really coincidental. And I will also say that the other thing I see is, as folks have described their paths, is there is sometimes like a tiny bit of serendipity. I don't want to call it luck, because luck, no, serendipity, that opportunities were available to you when you needed them. And I will also say that for me, there's one more twist to my path that I have to throw in, and that is a couple years after I moved back to Connecticut, I had an accident and am now in a wheelchair. And that meant now adapting how I do my research so that I can also function as a human being who can't go hiking over lava flows. So yeah, adaptability, find your niche, if you really want to do this, you have to love it. If you really want to do this, you will find that niche and you will find a way to adapt yourself to fit into those spaces. All right, I think we're popcorning to Ed now.
See, now I'm hungry with popcorn. So it all started when I was a wee little kid. So I was born in Arecibo, Puerto Rico. So for those of you who might be able to notice, behind me is an amazing huge dish with a dome at the top. This is the Arecibo Observatory. It was in PR. I grew up in the city where this was, and when my parents took me up there, I was just completely and utterly astonished that this amazing instrument that opens the entire universe up to us was in our backyard, basically. So that definitely like inspired me as a kid to know at the young age of 5 to be like, I'm going to do something that brings me back, that I can do this science. And so when I went off into after high school, I said, okay, the science that might bring me back is astronomy, and I like astronomy, so I'm gonna go do some physicsy astronomy thing. And so, but when I was looking for undergraduate schools, I wanted to make sure that I had more of that connection with the professors, that I wasn't a number in a large Sea of Humans. And so that narrowed down my options of where I could go. So I ended up going to this small liberal arts college in upstate New York called Alfred University. It was at that time the top leading teaching observatory in the East Coast. So that meant I could go and learn how to work at an observatory. So I was like, this is perfect. And while I was there, I was part of the honors program. And the geology professor who was going to offer the next honors class offered one in the geology of Venus. So at that time, I was just a physics and math major. And I was like, geology of Venus, this sounds fun. And so I took that class. And that's when I started going, okay, maybe instead of astronomy, let's bring it back closer home to the solar system because Venus is crazy. And then he offered a class in the geology of Mars. I was like, whoa, this is even cooler, the geology of the moon. And so I kept taking classes from him, and then I kept making him offer classes. And he probably thought I was annoying. But at the end of it, I invented a new minor at my undergrad. So now you can go and minor in planetary science because of all the classes I kept bugging him to make, and it was great. After undergrad, I went off to then University of Arkansas because they had a program in planetary science. And I wanted a program that focused on this interdisciplinarity of the field. And at the U of A, it actually connected 5 different departments. So it was physics, geology, the chemistry, the biology, and the engineering department all into one department. And so as a student, you had to take classes from each one of those different departments. And so I was like super excited to get to like learn a little bit of engineering, a little bit of geology, because I like to do a little bit of everything. As I was finishing my PhD, which was looking more at how water vapor moves around different bodies, whether it's airless and cold like Iapetus, or whether it's on Mars as the surface is breathing and maybe forming brines. But at the time that I was graduating, it was one of the big recessions. It was back in the 2012s. There weren't many postdoctoral positions open. And so I was applying to a bunch of different places. Speaking of serendipity, I had a colleague who we had done an internship together when we were in undergrad, and he at that time was a graduate student at Brown University who had just hired a professor who was just starting to look for a postdoc. And he was like, hey, why don't you just like come talk to this person? And so I did, and she hired me. So Amy Barr was my postdoc advisor. I got to work at Brown for 2 years. That was really cool and serendipitous. You want to know more serendipity? The economic crisis was still going. I was like, where am I going to find my next job? This is a 2-year postdoc. So I was complaining on Twitter back when it was good. And one of the folks who worked at the observatory, Sandy, noticed my stream of consciousness and was like, hey, why don't you apply to work at the observatory? We have a position open. I was like, what? I wouldn't have even had considered it because like, would you even take me? What? I haven't done radar. So she helped me get over the imposter syndrome behind like going back to the place that inspired me to go into science in the first place, because I also saw it as like the best place ever. And I applied and got to work there for 5 years. Best experience of my life. So I got to be an observatory scientist for 5 years. After that, I actually ended up coming to the Lunar and Planetary Institute to be a staff scientist there for another 5 years, and now I'm at APL. And so when we come back to it, I'm coming from the soft money side, and I saw somebody write in the chat about what is the soft money positions. I've experienced different types of soft money positions, and I'll chat more about what that looks like.
Thank you all so much. So we've received hundreds of questions from our participants, particularly when you registered, and I've kind of assembled them into a variety of topics. And that first topic was about our participants' own careers. And we've got some more questions for that, but I would like to get on to some of the other topics. One of the topics that's kind of important, it's sort of an elephant in the room right now, is the past and the future of careers in planetary science and astrobiology. And this can be related to the future, the growth or decline, job security, of careers in planetary and astrobiology, opportunities. So I'm going to let any of our panelists who would like to speak on this go ahead and let us know and we'll move on this one. I do want to save a lot of time for the idea of the different types of careers and preparations for those careers and how they differ from each other. So I'd like to save a fair amount of time for that.
I'm gonna quickly jump in on this because I mentioned that part of my career was during another uncertain time. And so from my own lived experience, what I would say is history is a cycle. There will be uncertain times. We live in uncertain times. We will come back to uncertain times. Hopefully one day we will be back at very boring times. I would appreciate that again. That would be great. However, one way to exist and thrive, or even survive, thrive is a poor word, survive in uncertain times is leaning into your network. The way I was able to find these positions was talking with other people so that I could stay in planetary science. Other folks also, from my own cohort, during those uncertain times, they took positions in, for example, financing, but they kept ties in the field. And when they were able to return, they were able to return. Careers are in that sense like a braided river. You sometimes, because of external pressures, not because of you or your own merit, because of external pressures, you end up taking one of those sidebar rivers. Eventually you come back and it's fine. We're all flowing towards an awesome ocean. But lean into your network.
You, Ed. Would anyone like to add on to that?
I would just say that I think any of us that have been to, there's one big conference in our field that's the dominant conference, which is the Lunar and Planetary Science Conference. There are others in individual fields. There's DPS, the Meteoritical Society, but Lunar and Planetary Science, you see if you go 5 years, 10 years, that planetary science and the topics that are popular or that more people are going into, they change really quite quickly. Absolutely not geologic timescale on this. So I've been going since 2002 and I have seen many trends come and go. And so I think that's one of the things about planetary science is that what is sort of being looked at and where then naturally the jobs are does change with time. But those cycles, like Ed said, they come and go. And just because maybe what you do isn't the popular thing right now, doesn't mean that it's not wanted, that it's not useful, and that it won't be the next big topic again. Or even that you necessarily want it to be, right? So I think that can be a real hang up sometimes, is that you go and you think, well, no one else is doing what I seem to be really interested in. Well, great, then we've got a gap for you, right? So I think that's really important too, to understand that this, if you're interested in this field is not static. It is fast moving. And I think it's a great community to be in. I'll echo Ed's leaning into your network. I have found such an amazing network in planetary science. Some amazing friends, but also colleagues who will rally in when you wouldn't necessarily think that you were that close. So it's a great field to be in that perspective, I think.
I wanted to just briefly add into this, and coming from the biological and chemical, what kind of wet lab sciences, maybe this is different for other approaches to the planetary and astrobiology sciences. But I feel also, I see it in a lot of my students, is that they are so interested in everything that astrobiology and space sciences almost in general have to offer, that they want to do everything all at once. And they tend to spread so thin their energy. And, you can never be an expert in everything, right? So, and maybe as you progress more in your career, it's easier because you're very well known for the two, three, four things that you're, like world famous for. And then you can like branch out and do like many crazy stuff. That's awesome. But my advice, and again, that's just my opinion, is that if you start from like your master's or even before, attempting to do nine things at once, chances are you're going to be spread too thin to really be like very competitive at that one thing. So my advice is become an expert in one, two, or three things, and then slowly you are gonna naturally grow out and do more things, but try not to do everything all at once. And the fact that now doing your master's or your PhD are focused on one and two topics, that doesn't mean that 30 years in the future you will still do this. Just don't feel like you're always missing out because you're not doing something else. You will, if that's what you want to do, you will do those things. Just learn and enjoy what you're doing now, and the good opportunities to like adjust your direction of the ship that is your life, they will come. Don't fret.
If I can follow on a bit with that, that actually is a great segue into where I was going to go with that. And that's find some skills that you are good at because it's something you're passionate about. Are you somebody who likes to be a lab rat? Get some lab skills, or do you like to write? Or are you a communicator? Or are you a speaker? Because the jobs are going to come and go, and there's going to be times when the funding is smaller and times when the funding is bigger. So if you're able to kind of step to the side in that braided river and take that side channel. So maybe, and I saw a lot of questions go screaming by about careers that don't require graduate degrees. There are opportunities in museums and in science communication. If you're passionate about science and you can communicate it, that's a fantastic direction to go. If you're a computer person who loves to code and be online, there are directions you can go with that in data science, machine learning, things like that. So get yourself a skill that is applicable across multiple domains. Don't just be like the Venus volcanology person. If your focus is on the very, very tiny thing, it's harder to get that job. If you can be flexible and say, hey, I'm a radar person like Ed, and I can study Venus, but I can also do these other things, then you can meld to the opportunity when it comes. And yes, you can get back to doing Venus volcanology, but you can pay your bills up until that point.
So what I'm hearing is that while right now there's a lot we don't know about growth or decline of these careers, what I hear is pretty much everyone thinks that in the future, even if the number of careers is available goes down, that it will increase again, is our anticipation. It's hard to predict right now. There's a lot of things when it comes to funding that are hard to predict, but yeah. There's a lot of questions about future careers, future jobs. Let's go ahead and move on to sort of that realm of our discussion now, because we had so many questions on it. And that is this idea of the variety of careers and what's required for each of these. So we've got, academia, nonprofit, museums, observatories, government, industry, and space policy. And so what's required for each of these? Does each require a PhD? Do some just, some of these might be, and earlier Nick had a thing about, technicians and engineers in planetary science, where they are not necessarily the ones, they're system engineering or things. All of those are related too. This is such a big field. These are big fields. Who would like to comment on any of this?
I'm
All
happy
right,
to start
yes.
about nonprofits and museums. Or did you want to go, Jen?
Let me jump in quick with academia, and then I think because academia is obvious, and that's really my background, so I can't, it's hard for me to speak on the other stuff. If you want to be a university professor, at least in the United States, you need a PhD. And this would be a professor, meaning this is your full-time job. It also is going to involve advising of students. It's could involve educational research or development of curriculum. You've got a wide range of universities. You don't have to go to the big fancy R1 where you have to have funded graduate students and all of that. You can work in a smaller institution where you're teaching more classes, but you don't have that pressure to publish and get the grants. Or you can go to the one where you get the grants and have the big stable of grad students if that's what you want to do. But you do need the PhD for that. And at this point, you probably also need to do at least one, if not more, years as a postdoc. And that's getting your research program off the ground so that when you transfer into that professorship, you are set to get your grants, get your publications. There is, though, sort of I don't want to say a lesser bit. If you only finish with a master's, you have potential for opportunities as either a part-time faculty member or a faculty member at a community college. And I don't want to say lesser, I just want to say it's different. You need less education to do those. There's less expectation of research. So at a community college, you're not going to have a research lab. You're not going to have a drive to do publications. But that could be something that you do through your coursework. So have your students in a class do a project. The drawback to part-time is it does pay less and it's not stable. So like we hire part-time instructors on a semester by semester basis. But it's a good way to get experience if you're out of the field for a bit because something dry, you didn't have a job, you could grab a part-time instructor position to keep yourself going. But you will need at least the master's degree to teach in most places. You could even go down to teaching at the high school or the elementary school level. That will require just the bachelor's, but probably a licensure for your state. Unless you teach at a private schools will take folks right with a bachelor's without a license or a master's degree in education. So I will leave the academia and let everybody else talk about the rest.
I'm going to pause really quickly. Thank you, Jennifer. I appreciate that. Yolanda, can you see right now our panelists aren't allowed to post to the chat to everybody? Can you see if you can figure out that and change it so that they can add to the chat as well? And who would like to go next? Rhiannon, do you want to go next?
Sure. So since my role is kind of half museum, I'll speak to that because the other half kind of overlaps with what Jen talked about. So in terms of if you are interested in working in scientific communication or public outreach, depending on the role you want in that, a bachelor's would be sufficient. So for example, for quite a while, I had an educator that worked in the museum that the collection at TCU has a beautiful museum attached to it. And so there was someone employed to work in that. And they had a bachelor's in education. They had actually spent 30 years in the classroom teaching environmental science. And were therefore fantastic to come in with that experience and do the outreach for the K-12 crowd. We actually do K through adult. I've just done a course for what we call silver frogs here at TCU, which is the retired horned frogs. So there are also a lot of opportunities, for example, in collections management, where you are helping the curator. And I had the computer science students at TCU designed me a new collections database, right? So there are opportunities at different levels to work in museums, and I'm sure Ed can speak a little bit to observatories too, that don't require the PhD. But if you're going to want to be there actively researching and working, chances are you're going to need that PhD. I would encourage people to reach out to these institutions. We absolutely a lot of them take volunteers. We have high school students that come in and do research. You can come in as a graduate student. I spent quite a lot of my graduate years visiting the Smithsonian, doing a lot of my research there, that's how I started to understand that working in a museum was one of the things that I really wanted to do. So it's never too early to start with that. A lot of museums will take docents very, very early on. And I saw someone dropped in the chat here that, you know, there's a science writing master's program at Johns Hopkins. I know that, I'm going to get it wrong. There's one that has the Alan Alda Institute of Scientific Communication. Is it
Stony Brook?
Stony Brook. So there are other ways to approach this. The Stony Brook program is fantastic. So you've really got to find what you're passionate about and pursue it in that way. Obviously, I came about this kind of differently. But there are opportunities at all levels. It just depends to what degree do you want to be involved.
Thank you so much. Ed?
Yeah, I can jump in with the observatory tagline. And also going back to a point from a question that was posted in the chat about soft money positions and what does that look like. So whenever you hear the term soft versus hard money, that category is saying about the requirement on the person to bring in external funding to pay for their position. Soft money scientist is required to bring in their money by asking NASA for funds or another organization for funding. And hard money positions do not require that. You can do it. You are not required. After I left Brown, after I finished my postdoc there, I have not returned to academia. I've been in soft money positions. So I got to work at the Arecibo Observatory as an observatory scientist. There, my position was primarily a community service position. So I was doing observations on behalf of people who would send proposals to the observatory for us to observe on their behalf. I got to, because Arecibo was the world's best radar. When NASA was like, hey, we just discovered this asteroid, we need someone to ping it, we would get those requests and I would come over and help out with that, help reduce the data, and also get to do community engagement. So I got to make sure that we were involving more of the island into what we were doing at the observatory. As Rhiannon mentioned, the positions at the observatories are not necessarily PhD required positions. So the scientist position, yes, there's also observatory support positions. Those don't require PhDs. And so, like I mentioned when I was going through my story, there was a person called Sandy at the observatory who was like, hey, you should apply. She was an observatory support specialist, is the formal name of the role. She was at that time had her master's, was debating about going to get a doctorate degree, but in the meantime, doing awesome work at the observatory. So she did not have to have a PhD to work at the observatory. There's also a lot of engineers who worked at the Arecibo Observatory. So if you are more interested in some of the instrumentation aspect of an observatory, whether it be radio observatory like Arecibo or an optical infrared, there are positions there as well, because these are large gadgets that need to be maintained. Those type of positions are still called soft money because we as a group, the scientists, have to come together and write a proposal to ask NASA every 5 years to come back and be able to support people there. After being an observatory scientist, I went to my next soft money position, which was at the Lunar and Planetary Institute. There I kind of call it a median soft money because part of the job, I didn't have to write that proposal to support part of my time. It was the powers that be who did that, but that part of the time was to, again, still do community service. So I got to help put together the Lunar and Planetary Science Conference. I got to help put together other smaller conferences like a Brines Conference, a conference on habitability, a conference on radar. I got to help do all that stuff. And then for the other part of my time, I also got to write proposals to bring in money to pay me to get to do research. At LPI, I also got to work with somebody else who didn't have a PhD. She was a research assistant at LPI, Betzada Ponte Hernandez. She was working on her master's degree at a local university, and in the meantime, also working at the LPI with me, getting to do research. So another example of you don't need a PhD to do science. After LPI, I came over to the Applied Physics Lab, where now the position, kind of over time, the amount of community service has decreased. So at the SeaWorld Observatory, it was like almost 80%. At LPI, it was like 50%. Now here, my primary role is doing science, but focusing on mission level science. So helping to create concept designs for future missions that we send out to explore the solar system, instrument designs, and getting to also work on different missions to leverage them to do awesome science. And again, another example of you don't need a PhD. The majority of people who work at APL are engineers, actually. And at the engineering positions, you don't need anything above many of them above a bachelor's degree. Some of them you might need a master's degree, but most of the positions you don't need a doctor's degree. So in those positions, you can come in with that systems engineering background and help out put together this mission concept that we're going to send to pick your favorite place in the solar system. So there are definitely different options throughout this, and each of these options come with different funding sources, whether you're the one who's having to write the proposal or somebody else is having to write the proposal. There's pros and cons to all these positions, but it's a fun journey.
Thank you so much. Eloy, have you had a chance to speak yet?
Yeah, I'm one of the boring university professors here, and Jen already covered plenty of that. But I would like to say that it is totally normal that all of these different possibilities and careers, like 5, 10 years into the future, look really daunting right now. But don't worry. If what you want to do is in this ballpark, you will find your way. And something that we have not really touched too much about is mentorship. How important is to have both a network of peers roughly in a similar kind of career stage as you. They can also mentor you in some things, but to me, that's part of mentorship. But I think also you need to find someone, and also this is often going to change as you progress your career, that is a little bit more advanced than you, not necessarily like 20 years ahead of you, but can like you can feel like comfortable asking all sorts of questions that you don't feel they're going to judge you. And don't think that you need to ask us what is written here. It doesn't need to be like a formal mentor, right? You don't need to be like, hey, do you want to be my mentor and like sign this contract? No, it's all about, finding someone that, you like and they like you, and you can ask and exchange knowledge. And there's plenty of people, many people don't like to be asked and they are not good mentors. That's fine. But there's plenty of us that, that's one of the things we love. So, talk to people in conferences, be open, and you will find plenty of mentors. Don't just have one, have many. Have one mentor for everything, different thing in your life.
Awesome. And yeah, thank you for preparing the slide. I'm going to finish adding a couple of the things that you have there. So there's a bazillion other questions and a bazillion other suggestions from folks. I want to go around and invite each of our panelists to share one way that people can get started in a career in planetary science or in astrobiology. So one way, entry-level positions, opportunities, whatever you can think of, one way for people to get started who don't already have their foot in the door yet.
I'm gonna very quickly start. So if you are a university student, so you are doing an undergrad, master's, I mean, if you're doing a master's that includes research, you're already doing this. But let's say you're an undergrad, like, oh man, this sounds awesome, but I don't even know where to start. So first thing, open the website of your university and look at all of the profiles of the researchers there and see if someone does something that is remotely similar to this. Chances are someone is going to do something that is at least adjacent to astrobiology and planetary sciences. If not, and you're unlucky, look in like the same city you are and look at other universities. Professors, we love to hear from people that are interested in what we do. So if you write an email to one of us, you're like, oh, I love this thing that you do, chances are we will respond. And then basically we're like, hey, I'm free labor, use me, I want to learn. So get into research and don't be afraid of asking for professors to join their labs.
And I would follow that up by saying, again, focusing on undergraduates, particularly those that are maybe at institutions where there either isn't much planetary science or there's not much opportunity for research. There are a lot of internships available for undergraduates. There are the research experience for undergraduates, the REU programs that are nationwide here in the United States. I confess I don't know what that's like outside of the United States. But a lot of these opportunities are even open to international students. Apply, apply, apply. And getting that research experience can be so validating. For some people, it might be, man, this sounded great, but research sucks. Right? And for others, I mean, it's just, we all love different things. For others, it might be, this is really what I want to do. And then not only do you have research under your belt, but you have another person outside your institution to write you a recommendation letter. Also sort of picking up on what Aloy said is when you are reaching out to professors, do your research. I get so many emails asking me, applying for grad school, and they're like, I am getting my undergraduate in agricultural sciences, and I wish to continue this with you, right? And it's clear that they've just email bombed my entire department and not looked in at what I specifically do. So if I get an email that says, hey, I'm an undergraduate at this institution, I'm really interested in planetary science, I see that you do this, what opportunities do you have? I'm really interested. That's different to me, and I'm going to take the time to respond to you. But I can't emphasize that enough. If you use the same email for all of us, your response rate's going to be a lot lower.
And I'll piggyback on that. And I keep coming back to this idea of being flexible is when you do come to these professors, don't come to, come to us with your skills and say, I'm good at coding. I'm good at organizing. I know spreadsheets really well. Is there something that I can do that's relevant to what you do? Because if you come in with, I want to do Mars geology, and I don't, and that's not something we have an opportunity for, then we might have to say no. If I had come to that when I went to do my undergraduate research, I wouldn't be here. I needed to say, yes, I love Mars geology, but you do asteroids with telescopes. So I have to learn how to do that. So be willing to be flexible, but also if you've got that passion, you're like, okay, I can do this for a couple of years and then go do what I really want.
And I'm going to echo and agree with a lot, but expand in that internships, I think, are a great way of getting into the field. ADESIWO had its own internship program. The LPI has its own internship program. So you don't necessarily have to go to a university to work as an intern. These internship programs also pay you, pay you to also fly to the place and a bunch of other support. And internship programs aren't only for undergraduate students. There's also internships for graduate students. I did both an internship as an undergrad and a grad student. APL has several internship programs as well that folks can apply to. The spin I'm going to add to the internship in terms of breaking into the field is if you go to the internship program and you just do the research, you've done only half of the job. The biggest and most important aspect, the next part, is networking. Know your colleagues who are in your internship program. Get to know them by name. They're your new friends. Walk around and talk to all the other folks who work at the institute, the university, or a place like APL. Talk to folks. Get yourself known, because it is that network that will help you out throughout your career as letter writers, help you out as potential mentors. We're a community, and these programs are ways to get a step into the community.
Thank you all so much. There's a couple of things, there's so many questions that we didn't get to, but our next session, our next webinar is going to be on this idea of braided river careers, on switching from, okay, so you have programmed experience, knowledge, background in biotechnology or in electronics or whatever the field is, and switching into and out of a career and how a career changes over time. So we've got some great speakers for that. We hope that you'll join us for that. And you can see the website here, and it should appear as well in a follow-up email, hopefully. And then I also wanted to let you know we do have some resources online, including news for students and early career researchers on a variety of topics like upcoming events and fellowships and scholarships. And if you have something you'd like us to add to this website, to this newsletter, please let us know. Please email us, Yolanda or myself. You can reach us at education@lpi.usra.edu. I've got a survey that's popped up right now that you are welcome to fill out here. If you had to leave and you didn't have time, you should also get an emailed version of the same survey. It's exactly the same. Don't fill it out twice. Please join me in thanking all of our panelists for sharing so much of themselves, their careers, and their time with us today. So please join me in thanking them. And apologies that we weren't able to get to everybody's questions. We will be having others. We'll add several more topics. There were a lot of questions related to grad school and related to internships. Maybe we'll have to have some of that. And then also for our early career researchers who are dealing with trying to find how to stay afloat in today's challenging environments. And so recommendations for those types of questions are also very welcome. We'd love to hear your thoughts. Thank you all so much for joining us.